idea. The main keyword there is no blocking. So, and typically we use it when we want to do some input-output. When we want to read from the file system, we don't do blocking. We do it asynchronously. When we want to get some data from another server, remote server, we don't do it synchronously. We do it asynchronously. So this way, the user have a better user experience. The page does not get blocked. And for the server side, if we use this asynchronous programming, it improves the scalability. Since like the request handler does not need to block and does not need to use multi-threading to handle requests. So today I want to quickly review this just to make sure everything is clear. And then we build on this to move forward. So what are the three? Well, basically, when I am creating an asynchronous function, when somebody calls this function, they cannot just call it and wait immediately for the results to come back, the way we used to do it in the past. Instead, we call the function, and then what we do when we call it, we pass it the input parameters plus a callback function. What this callback function is for?
It's called like after we finish the...
Yes. Once the function we have called is done with its work, it calls us back. It calls the caller back to give it the return value. So an asynchronous function does not return a value. Instead, it calls back the caller and passes to it either an error if something goes wrong or the actual return value if it was successfully produced. So one way to do it is using callbacks. What is the problem with callbacks?
We can go with like multiple callbacks.
Okay. If you are doing it for a simple task, there is no problem. Callbacks are perfect. They work nice. No issues whatsoever. But the issue starts to show when you have calls that depend on each other. You have to do multiple steps to achieve certain tasks. And this is basically, we can call it like function chaining. You connect multiple function calls. So for example, anybody can give us an example of multiple steps to achieve certain goal?
If we read from a file,
okay.
Then we want to read from another file and make it like a relation or something.
Okay, something a little bit more concrete. Yes?
The server itself, server concept, when you call from a server and that main server will call another server from another domain. So this is
Yeah, I understand, but it's a bit more concrete, a concrete example. Let me give you one, for example. Yes, please.
Like if you want to get an instructor from a course from a student.
Okay, kind of, yes. Let me give you a little bit more concrete one, very concrete. Let's say I search for students by surname. Okay, so I get the student details from the student file. Okay, and then based on the student's ID of that student, I will go and look up the courses that they are taking. Then I get the list of courses. Now those lists of courses, they have an instructor ID, but I don't know the full instructor details. I can't go to the third file to get the instructor details. So these are 3 steps to give you full details about the student, their courses, and the structure of those courses. So those full details, how many steps I need to do? 3 steps. And all these 3 steps are asynchronous calls. And basically, the callbacks get nested inside each other. And then suddenly, we get what is known as a callback hell or callback pyramid. I will show you how it looks in real life. And basically, when you are composing or when you are chaining multiple asynchronous functions, this becomes problematic. Then, in 2015, there was a new feature in JavaScript called promises. That was invented or was invented to solve this problem of callback hell. So what is a promise? Even in real life, what is a promise? in plain English? What is it?
The loan example you've explained.
Okay.
So they give you the money, and when you promise that you will pay it back according to whatever guarantee you have.
Yeah, I mean, okay, yes, but let's say, so it's something basically in the future. When we say promise, it's not something now. It's something related to future. It will be, and promises, it will either be in the future, it will be either fulfilled or rejected, or it will not be fulfilled. That's what promise is. Something in the future, we hope it will be realized and it will become reality, or something might happen and basically something might happen and that promise will not be achieved or not be realized. So promise is, in this context of JavaScript programming, promise is a future value. So now when I think about this problem of asynchronous programming, I no longer think in terms of callbacks. I think in some other ways. So a function, when asynchronous function, instead of returning you a value, what does it return you? A promise. Are you following? The functions you have seen before this session, before this week, all the functions you have seen, when you call them, what they do? They return you a value. Okay? Those are synchronous functions. They are very good, but the main problem, you have to block and wait for them. Yes?
Yeah.
Now, to do it asynchronously, you have either to use callbacks or promises. Promises means the asynchronous function will return you a promise. Take that promise, keep it with you, and move on with your life. Don't block waiting for the results. Later, all you need to do, you kind of take that promise and associate to it a function. You might think of it as a kind of callback function, but you do it yourself. You go and say promise. If it's achieved, I will do it then and handle when the promise is fulfilled. Or I will do dot catch to catch any errors. Are you following? You see the it's a kind of a different abstraction, a different way of looking at the issue of asynchronous programming. So then promises are very nice, on top of which lately in 2007 and just last week they basically released the new version of Node.js that has built-in support for this. In fact, the examples that I didn't push yet, the examples, just I think 2 weeks ago, you had to compile because basically this async and await was not natively supported in Node.js. Now it is natively supported. That's why in the lab, first task you did is you upgrade it to the latest version. The version we installed at the beginning of the course, if you did not have this built-in. Now it has it built-in. In fact, I have changed my examples to remove that step of compiling. Compiling means when there is a new feature in JavaScript, there are libraries that you need to add to use that new feature. But with the time, you don't need extra library, it becomes part of the runtime. Part of the Node.js on the server side and part of browsers, especially Chrome and Firefox, they are always up front in terms of supporting the latest versions. Okay, so the async and await, they make our asynchronous functions, they look exactly the same as synchronous ones, exactly the same. Except we annotate, we come to the function when we say, oh, by the way, be careful, this is an asynchronous function. And here, for when I call an asynchronous function, when I call it, I say, be careful, this is an asynchronous call. And I put there await. So now I hope, at least conceptually, you get the idea and you practiced it a bit. So let me show you one more example, just to kind of close the loop and see if it's clearer to you, and then we move on. Yes, please.
As we know, like JavaScript is one embedded language. How can it do multitasks and it's one-threaded language?
Okay, very good question. Okay, so JavaScript is a single-threaded language. Now, the way it works is that for long-running tasks, which are typically input-output tasks, for input-output, so let me maybe use some drawing today. Hopefully I have a pen. I have to stay close to this guy. Interesting. Okay, this is good. Very quick. So a single-threaded application means, I think in operating system you've seen how a program is executed using a call stack. Are you familiar with this, call stack? So each thread has a call stack. As you call functions, they get pushed into the stack, and then when the function returns, pops out from the stack. Okay? So the problem here, this is a stack. Now, if you have some function that is long running, it will basically hold the stack and block everything else. You can't do anything until that function finishes. So basically, if you are doing some simple computations, additions or whatever, some simple computation, they run on so when you run a script, it will run on a thread, and script is made up of functions, so they will run using the normal stack that you are familiar with, you saw in, let's say, operating system. Now, when there is anything to do with input-output, what I mean by input-output, reading from files, writing to files, or reading from a remote server, or sending data to another remote server. Those are long running. Are you following? So those, I never do them synchronously and put them in the stack. Why not?
They will plug this.
They will block, because there is a potential, because you are talking, let's say, to a remote server, maybe I'm not sure, in Dubai or in New York or wherever it might be, there is a network between you and the target server. And there could be delays, there could be congestion, the server could be busy, anything could happen. You don't want to block other functions from keep doing their work. So what happens is the JavaScript runtime, either on the browser or on Node.js, they have, let's say, a pool of threads that you don't manage. We don't manage ourselves. Okay, the runtime runs them. So pool of threads that they will handle input-output. Okay? Now, when I say go to this URL and fetch me the data from that URL, does it run on the thread where the script is being executed? It does not run on that thread. It runs on another thread that you do not control. Now, how does the communication between the main thread and your thread, the main thread and the input-output, like let's say reading from an URL or from a file, how they do communicate? How we communicate between the main thread and the other input-output threads is basically what happens is there is something called the event queue. So let's say this is the pool of threads that they take care of input-output. Whenever I need to read or write to files or get, fetch, or post data to a remote server, that code will run asynchronously in these separate threads. Now, once, let's say I asked for student.json file. So once this file is ready and the results are ready, then basically a callback will be added to the queue. We'll say the student data is ready. Remember, let's say if we are using callbacks, we have specified the callback function. So that callback function will come here and say, let's say display. Remember the callback function?
Yes.
Let's say called display student data. So this thread responsible of input output, when the data has arrived, what it will do, it will queue the callback call into an event queue. Now the JavaScript runtime, it has what is known as the event loop. What this event loop does, it watches this queue, and whenever the stack is empty, it has to be empty. Whenever the stack is empty, it will take these queued functions and execute them. So this one is never blocked, and anything to do with input-output is done transparently in another pool of threads, in another pool of threads. When the results are ready, the callback function, the data is passed to the callback function, and the callback function is queued for execution. Once there is an opportunity to execute the callback, it will be fetched from the queue and put in the stack for execution. You get the idea. That's basically how it works. So, and this one, that's what makes Node.js very, very successful. So instead of when a request comes, we create a thread to handle it, we have only one thread. And we have a pool of threads to handle the long-running operations, which are typically the input-output. So here is the conclusion. Node.js and JavaScript in general is very, very good when you have a lightweight computations. If your application has heavy computation, you do lots of computation, then Node.js is not very good. It's not good for you because it's single-threaded. But typically, in Node.js, you will be doing a reading from some database, doing some simple computations, not heavy computations. If you want heavy computations, you have to go to some other platform, like C++, some other platform that is based on threading, based on other mechanisms. But this one is optimized. If you have a backend systems, could be other systems or other databases or files, and you just want to talk to these other systems, get some data, talk to multiple systems, aggregate the data, and then return it, or do some simple computations, then this is perfect. It works very well. But if you have heavy computations, then forget about it. CPU intensive. Sorry?
What language will servers use?
What language?
Servers use usually.
Now, for web applications, usually web applications by nature, they are not computing intensive. When you go to a website, you basically think about whatever website you are doing. Whenever you are let's say you are processing an order, the web application receives the order and places it into a system, another system, let's say ERP system or order management system that will do the long-running processing of the order. But the web application to receive your order and store it or put it in a queue for processing it, it's not computing intensive.
Yeah, I mean for the system itself, for the ERP system, for example, what language would you use?
Okay, for those like maybe Java, maybe .NET, maybe C++, and those things. So Node.js is perfect for web applications. Okay, it's perfect for web applications that are interactive. When I say web applications, they are interactive between the users and the system. And those by nature, you know how users are very patient and they have plenty of time and they can wait for you forever and you can take your time. That's not the case, isn't it? They want instantaneous. If it's before even they click, they will be happy. So that's why this is perfect for this type of things. It's also good for what is known as web API. API means I can programmatically get some data from another system. So the actual heavy computation is done by another system. Let's say a database that will do the actual querying and actual getting of the data, the Node.js or JavaScript engine is just kind of an intermediary that will make that application accessible to the web. Yes? Is this clear? Does this answer? So this basically is the secret. This is this event loop, and there is this queue. So really what happened is, when you say this await, you have seen async await. So await, all it does, that particular function will go to the queue until the data that is expected by that function arrives. Then it resumes execution. You seem like sometimes some people, I'm sure, if you are doing paperwork yourself, I'm sure you have seen this type of scenario. Let's say people are queuing to get some service at some government department. And sometimes you need to fill up a form. And this guy suddenly comes and says, where is your form? I didn't do the form. So there are two scenarios to handle this. What are the two solutions? Either you do it now, and what happened to the queue? Wait, they're happy?
No.
Of course not happy. So that's blocking. You basically blocking lots of people just to keep that person that didn't do their work happy. So what's a better solution to do it? Step aside. Do it and come back. I will not put you again on the queue, but I go aside once you are ready. Go aside means go to this queue. Once I am here, don't bother me when I'm serving other people. It's not fair. It's not fair. It's not polite. Once you see me like I don't have anyone serving, what should you do? You come in. I serve you. That's exactly what's going on here. It says, okay, once the stack, this is the employee. Once they are finished, once they don't have anyone they are serving right now, you have kind of priority. Just jump in, get your work done, and move on. This is exactly what's happening. So that await is a really say, okay, you are calling this remote server to get the student details of the courses. You are calling, let's say, Banner. Say, Banner, please give me the courses that students 1, 2, 3 have completed. So we're not going to wait for Banner to do it. Sometimes, sometimes Banner has its own mind. Sometimes it's fast, sometimes slow. So we're not going to take any risks. So what I do, I make that call, and then I'll wait. Await means it's not block. Await is not blocking. I'll continue execution. So await means that whole function will go to the queue. Once Banner make up its mind and it's ready and it provides us the data, we'll take that function, put it back in the stack for execution. That's basically how it works. And this is very, very scalable, very widely used. Sorry, I will show you evidence why it is so widely used. Okay, so is clear? So that's it. These are the 3 ways. Let me now just very quickly go through one more time how it looks in code, and then we move on. That's it. All right, so here it is. And it is kind of, how can I put it? It is kind of progression. We went from callbacks, and then we experienced with them, we had enough headache with them. Now it's let's move on from callbacks and do promises. After a few months, we had a better idea. Let's do it using async and await. But you will tell me, why do we need to know all of this? Why can't you just jump straight? You have to understand the whole thing, because in real world code, you will see all of them. But if you, as I mentioned, if you are starting from scratch, then you will use async await and maybe promises, but not callbacks. But you will find some libraries, some existing code uses callbacks. So you still are familiar with the idea, and you can still use them comfortably. Okay, so very quick here, let me show you the example of reading files using callbacks. So this is how it works. I'm sure you have seen this. So I have this fs object, and it has this read file.
Yes.
Read file means I am dealing with disk. And you know, in a computing environment or in an application, the part of the application that takes most of the time is reading and writing, because the reading and the writing is much slower than doing computations. So reading and writing to disk, or fetching or posting data to external services using a network is always done asynchronously, never synchronously. Okay? So when you say read file, is this a synchronous or asynchronous? It's an asynchronous function. So when I call it, what do I pass to it?
The path of the callback.
The file I want to read, and the callback that the read will use to call me back and give me the data that the read file has read from the file. Yes? Is clear? Okay, so now this callback function, typically, this is a convention. It has two parameters. Error, if something goes wrong, we will pass it to the caller in the first parameter. Otherwise, if everything goes well, I take the data, convert it to objects, find the student that I'm looking for, because I'm looking for one particular student, not all of them. And then I am saying, if I find it, I will call back, the error will be null. There is no error. You get what you asked for. Else, if the student does not exist, I will raise an error, say not found. Is clear? So this is an asynchronous function. If somebody wants to call this fetch student, what they have to pass? The student's ID and a callback. What do we use the callback for?
After finding the
Sorry? Not to block, and also to return the results. You see how we return the results? I don't do return. It's not like the conventional synchronous. In convention, if it was a synchronous function, what would I do? Return. So instead of doing a return, how I am passing the results to the caller? By calling them back and giving them the data they requested in the second parameter. Why did I put null in the first parameter? Because no errors. Everything went well. Is clear? So let me show you how we call this function. Here is how we call it. So you have a look. Fetch, I give it the student's ID, and I give it a callback function. Error and student. And then here, if everything went okay, I will get the student. Otherwise, I will get an error. Here I'm lazy, I didn't do the error handling, but I should have done the error handling. Is clear? Now, this one is simple, no problem. You say to me, callback, I'm great, we don't need anything else. But wait, when things will get a bit complicated, because let me show you. Let me run this and just show you quickly. When I run this, okay, you can see here the results. See here, okay, no problem. This is the first student, first name, last name, no problem. Everything is fine. But what is these? You're telling me courses IDs. Are you expecting me to know these IDs?
No.
This is not a very good user experience. You're telling me this is the student, this is their course, 107, 300, 127. So what do we need to do?
But then
Go and look up some other file or some other database and bring the details of these courses. Are you following? So what do we need to do? Create a function to get the courses, the course details for these. So 107 will be general engineering, 107 I think ethics, engineering ethics, 300 numerical methods I think, 127, whatever they want. Okay? So that's what the goal I want to do. Now, this get courses, will it be a synchronous or asynchronous function? Asynchronous. Whenever we need to read from other source, it is asynchronous. There is no escape. You can't tell me, okay, I like JavaScript, but I'm not going to go into this asynchronous path. I'll say, sorry, look for something else. JavaScript is all about asynchronous programming. Okay? So you need to be familiar with this. So here it is. Here is my get fetch courses. What does it take as an input? the list of courses, the array of courses, and because it's asynchronous, it receives a callback. All right, so it is time I don't go to student.json, I go to the course.json. If there's an error, I call you back and say, sorry, this file does not exist, or you don't have a read access, or whatever error might happen. Or this file is corrupted, whatever. If you are lucky and everything went okay, you will end up here. And then I'll get all the courses, but I filter only the ones that are within that list that you gave me. Okay? So I use this index of and find out. Anyway, then if everything goes okay, these are the courses you are looking for. So how do I give them back to you? Do I do return courses? No, that is in the synchronous world. In the asynchronous world, how do I return you things? By callback. So I say callback, give you null. Why null? Because no errors. And comma and give you what you asked for. Yes, please.
So now callback is a built-in function in the JavaScript.
No, it's not a built-in function.
Or we
You can here. You mean this one confused you? No. This is a name. This is a name that I might call it callback. This is a function that I will be receiving from the caller. When you call me, when somebody calls this function, what they need to pass to it? No, it will need to pass a list of courses and a function. Remember, a function in JavaScript is a kind of some kind of object that you can pass around as a parameter. We have seen this. This should not scare you anymore. So here, this is an input. Any input, when I receive it, I have to give it a name so I can deal with it. Same thing here. What's this? This is an input. What is it? It's an array of comma delimited numbers. Yes? What is this?
A function.
It's an input. I can call it whatever, X, Y, Z, whatever I want to call it. But maybe callback is a good name for it. So it's nothing to do with the built-in function. No.
So what is the implementation of receiving callback?
Okay, very good. Have a look at this. Here is the find. Here is the find. Have a look. Here is fetch student. So let me show you. Let me go back to this one. Is this one clear to everyone? What I'm doing, what this fetch does, what does it receive as an input? Student's ID. You are looking for a particular student, student 1, 2, 3, student 5, 6, 7, whatever it might be. And then, if you call this function, do you have to wait for it to receive the results? No. So how does this function communicate back to you the student details that you are asking for? It will call you back. By the way, the programmers or the people who invented this, they didn't come from some other planet. They live among us. So basically, we know this scenario. We do it all the time. When there is something longer, you request a service from someone. And that task is not like this. It's not very fast. You have two options. Block your life, do nothing, and waste your time. Or give a number or address or whatever. When that person finishes doing the service you requested to do, what they will do? They will call you back. And either if you give them an address, they will send you the results of their work. Or they will call you back and they pass you come and, let's say, collect it. Yes?
I have a question. If I define the callback outside the function,
Yeah.
Can I?
What do you mean you define the call? The callback is outside this function, definitely. Callback is a parameter. So remember, say, okay, let's make it very, very concrete. You have this dress, okay? You are invited to this big party and you want to, let's say, prepare this dress, okay? So you go to this laundry, whatever it might call itself. What do you give them? What's the input you give them? You give them first the dress. Please fix this or iron it or do whatever to it. And what else you give them as an input? Good night. Yes?
If I have the function, like I define the callback outside the
You must define it
why I give
outside.
it the function? Why I send it as a parameter? Can I just call it after I finish? Like just call back?
No, no, look. This guy that you gave them the dress, how they will get back to you. You have to give them some mechanism for them to notify you that what your requester is ready to pick up.
Like before we used to define a function outside another function, and if we want to call it, we just call it without passing the function or passing the...
That is different. That is, let's say, okay, here, basically, what you're saying to me now is that you have a number, you can give it to anybody to call you. Okay? You can give it to your friend, whatever. But in this particular context of asking a service for someone, you're giving your number as a mechanism for them to get back to you. What I mean, your number is useful in other contexts. But in this context, why are you using the number? You're not even supposed to give a number to strangers. Okay? But why are you giving the number in this context? As a mechanism for them to get back to you. Yes? So, for now, let keep it like kind of mechanical until really you really master it. All you need to think of this, all you need to really understand at this stage, an asynchronous function is a function that takes the normal input parameters that you are familiar with, plus an extra function. You pass it as a parameter to this asynchronous function. The asynchronous, and you can go on with your life, do whatever else you want to do. Now the asynchronous function will do its work. When the results are ready, how it will communicate it back to you?
Okay.
By calling the function you passed to it as a parameter. Yes? So,
Like if we remove the callback from the parameters,
yes.
will we get an error?
So in here, it's as if you gave the dress to this person
But I
and
have
you
the
walked
callback-
away.
I have the callback defined outside, like for the whole...
What do you think they will go to the phone directory and they will look?
Yeah, I mean in the code, like in here. We have it.
No. It's like you are telling me, yes, your number is with Uridu or in some book or somewhere. You're asking, basically expecting this poor service provider to go and say, have you seen this, let's say, this, what is it? Sorry, what's the word? Have you seen this nice lady? She's, how much tall? He doesn't even know your name. So how they will know which number to call? You know what I mean? You must be very explicit and you say, oh, by the way, here is my number. Yes, your number is available, but you have to tell it. Otherwise, in here, which function should I call? You have to explicitly say, oh, by the way, when you finish, please call this function. So what's the problem you have with this mechanism? I mean, it's very straightforward. Like, if I am calling another function, I might call it for other purpose. But in this context, I am using the function as a mechanism to communicate back the results. Yes, that's it. Yes, please.
No, I just wanted to say, like, the function, the callback, it's the way you connect, like, the girl and the dress. That's how you connect.
Yes, that's the way.
Like,
Yes.
can you show us how you call this?
Yes. Okay. So this implementation is clear, not confusing. Here you can call this one whatever, X, Y, Z. ناديني لما تخلص. اتصل بي. رن لي. Whatever you want to call it. It's up to you. It's really up to you. Okay, that's it. So here, when I call it, here it is. When I call it, I pass a function to it. Okay, this function, if this one is like confusing you, I can give it a name. I can call a function here. Let's say display. If you wish, you can do it this way. Nobody does it this way, but just to show you. This is a function. It takes two parameters, error and student. And when I say fetch, I say, oh, by the way, give me this student, and when you finish, please call me back on this number. Here we don't have numbers. Uridu will be very happy if we have numbers here. We don't have numbers, we just have functions. So in here I say, okay, call this, when you finish, please call this function back. Yes, are you ready? Is clear? And then basically, when the fetch finishes, it will call this function. What error will if everything goes well, what the error will be? None. In here I'm not handling it just for simplicity. And what this will be?
Just
the student details. And then I can do whatever I want to do with it. Display it, send it, whatever I want to do. Yes.
I know this topic, it's a regular headache. How does JavaScript know that this one cannot be in the stack? It has to be in the event queue.
Okay. Look, so the read function. This is a very good question. Have a look at this. Here is the read function. Can you see it? Read function. This read function comes from this package called fs. This read function, when you run it, where does it run? Where does it run? In the stack or in the pool of threads? In the pool of threads. When it runs, that function has associated with it a callback. So it will run, it takes 1 second, 1 minute, 1 hour, we don't really care. When it's finished, what it will do?
Go to the event queue.
No, what it will do, it will place in here, what it will place?
They call it.
It will, in our scenario, it will place a call for, where is it? Display. What it will pass as a parameter to that display? Null and the student details. Now, this one will be in the queue. This is busy. Your thread is busy with other things. But at a certain stage, it will become idle. Once it is idle, what will happen? There is a loop here, somebody watching this queue all the time. Okay? Like this guy, you know, when we're in the queues, there are some nice guys and they say nicely and they say, please come, please go forward. This is queue number 5, queue number 3. And they dispatch people. Okay? Same thing. Their job is just to watch the queue and say, because some people get, especially with phones, they forget themselves and the queue gets blocked. So this guy is facilitator and say, please sir, move forward. And then it goes to the stack. But they will only, if the other service provider is busy, they will tell you, please go forward. No, you have to stay on the queue. You get the idea? That's exactly how it works. So sorry, give me 1 minute because I don't want to come back to this one. Now, when it comes to connecting, this is where it becomes a bit hard with callbacks. In here, I'm doing 2 asynchronous functions. One, I get the students. Once after I get the student, I do another asynchronous function to get the courses. And then I put the courses in as a property of the student, and then return it to the callback through the callback. You see here, I have a function within another function, and if this one, let's say in courses, I have to get the instructor, I have to put getting the instructor inside here. So the code grows not only vertically, it also goes horizontally. It becomes like a pyramid. Pyramid, where is the, yes, this is like a pyramid. It grows like this and like this.
Yes.
And this is called, basically, is in developer, in JavaScript community, they call it callback hell. When you have a nested callbacks, this becomes very, very hard. Now to solve this, promises allows us to solve this by, instead of, you see here, you see in here, for example, when I say callbacks, let me show you. In here, when I return, have a look. This one, I return you a promise. I return you a promise that later on I will give you a student. Not now, this is a promise. Now when you call this function, you basically can listen on the promise. You say, I call student. When in the future I get student, I will then call courses for that student. When I get those courses in the future, I'll then call get the instructor of those courses. Then, only then, I can return the actual student.
Can you just promise it all?
Okay, this is very good. Like in here, I have many courses. I have to go and get the instructor of each course. So I do multiple calls in one go. It's very, very powerful. Here, I am calling for each course, getting the instructor of each course. Instead of doing a loop, I do it in one go, in parallel. So it's very fast, and it is, I don't need to do loop. Remember, students have many courses, and each course has a different instructor. So I'll have to go, course 1, what is the instructor? Course 2, course 3. Now I say, do it all in parallel and get me the results. Okay, so this is much nicer, and if the code is growing vertically, not horizontally. And basically, async and await takes this one little step further to make it even clearer than this. I hope now it's clearer. So I really appreciate you go through this. So next time we move to another topic. If you have any questions, prepare them, we can discuss them. Okay, thank you.